Section 2 in Chapter 14 of the Klein Organic Chemistry 2nd edition textbook talks about naming ethers. Now there's two different ways to name ethers, and generally professors will ask you to provide an acceptable name for an ether. If it's a very simple ether, you can name it as a common name, and if it's something more complicated, you're going to have to name it systematically. So I'll take you through the process here. Now there's two types of ethers that you can have. You can have symmetrical ethers. Symmetrical ethers are going to have the same group attached to oxygen. This right here is called diethyl ether. There's an ethyl group attached to the oxygen on the left as well as the right. This is sometimes abbreviated ET2O, and it's used as a solvent when you make Grignard reagents because it stabilizes the organomagnesium reagent. So if we have something like this, and we want to make the organomagnesium or the Grignard reagent, we do that in a solvent known as diethyl ether. We'll see that ethers are very unreactive. They make great solvents. They're organic solvents that dissolve things. So here's your Grignard. Okay, so that's just a solvent, and remember, unreactive things or solvents or catalysts we place under the reaction arrows in organic chemistry. How about another symmetrical ether? That's an isopropyl group here. So this would be called di-isopropyl ether. And it's interesting, you know that it's an ether because the ending of the name is ether. Now let me introduce you to some unsymmetrical ethers. Now, the only thing you need to watch out for here is that you need to alphabetize the groups. So if you have an ethyl and a methyl, you're going to name ethyl first because E comes before M in the alphabet. And here we're talking about very simple molecules that you can name as a common name. All right, so how do we name this? Well, there's 4 carbons on the left, so that's butyl, and there's 2 carbons on the right, which is ethyl. So you need to alphabetize butyl before ethyl. So we would call this butyl, ethyl, ether. Okay? This guy here has a tert butyl group. It's always confusing for me even to remember that you alphabetize tert butyl based on the B of the butyl group. Okay? And on the right, we have a methyl group. So the name of this molecule is tert butyl methyl ether. This has an acronym for the incorrect way to alphabetize and name the substance, MTBE. MTBE is an anti-knock additive that used to be added to gasoline. There were some underground gasoline tanks in Santa Monica that leaked. MTBE has a slight water solubility. It got into the underground water supply of that city, and it doesn't biodegrade very quickly. It has a persistent taste and a persistent odor in very, very small amounts. So there wasn't a lot of it in the tap water that was coming out from people's homes, but they could smell it, they could taste it. It outraged the city. They successfully sued the petroleum manufacturers, and there's a number of ongoing class action lawsuits in the United States still on this chemical. It's no longer added to gasoline. Okay? Ethers are very stable. They're used as solvents, and if you spill some of it on the ground, it's going to stay there for a long time. Okay? Let's do a couple more. And let's switch to not common names, but more complicated ethers. Okay? Complicated ethers require a systematic naming. Okay? How do we name this? Well, gosh, there's two ethers, aren't there? So what you need to do is identify the more complicated substituent. And when you identify the more complicated parent, I kind of chuckle at that. You know, are you going to pick your mom or your dad? Bad joke. All right, so what you want to do is select the 6-membered ring here as your more complicated parent, okay? Because the two side groups just have 2 carbons on them. So that's going to be the parent compound. That's called benzene. Okay? And we have a substituent at carbon 1 and a substituent at carbon 2. Now, the names of these substituents are going to be called ethoxy. All right? Ethoxy. So it includes the ethyl group and the oxygen. And so the name of this would be 1,2-diethoxy benzene. Okay, so we have no kind of clue in there that that's an ether based on the ending of the name. Let's do another couple ones. All right, so what do we do here? Well, there's a chlorine, there's, you know, it might be a complicated molecule to name as a common name. We can't because it's too complicated, okay? That group on the left isn't just a simple cyclopentyl group, it's got a chlorine attached to it. So once again, we identify the more complicated parent. Okay? I would just select that there, not the chlorine group. And so then we identify what groups are attached. This is a chloro group. And an OCH3 is a methoxy group. Okay? Then we can number and name the substituents, alphabetize, and assemble the name. So this would be called 1-chloro, 2-methoxy, cyclopentane. Okay? So when you have a really simple molecule, you can name this as a common name. Here it would be ethyl propyl ether. When you have a molecule that's rather complicated, all right, we would like to name this ether as though this were a substituent. Okay, so 3 carbons is propane, so we call this propoxy. Prop, oxy is the name of that substituent. And then we've got a couple of methyl groups, and then you've got to number and make sure you have the lower numbering. nonane derivative. Okay, we've got methyl comes before propyl in the alphabet, so this is going to be 3,7-dimethyl. And we've got the propoxy at carbon 4. And 9 carbons is nonane. Okay? So let's just review here briefly. We would call this a methoxy. 2 carbons is ethoxy. 3 carbons is propoxy. Okay. Butoxy, pentoxy, hexoxy, you know. Okay? So meth, eth, prop, and you just add the oxy right for that oxygen. So I think you've got the basic idea here, how to name very simple symmetrical, unsymmetrical, and more complicated ethers. All right, let's do a couple of practice problems in 14.1, problem A and B and D, okay? So first of all, this is a very simple molecule, so we're going to name it as a common name. We just need to identify the 2 substituents here. This is an ethyl group, and this is an isopropyl group. We abbreviate isopropyl with the I, but tert-butyl with the B, because there's that hyphen there. It's very confusing. I have to remind myself when I ever name something, okay? But E comes before I in the alphabet, so we're going to name this ethyl isopropyl ether. (14.2b) contains a stereogenic center. Now, this is a complicated molecule. It's not a simple alkyl group there. So we identify the more complicated parent. And so that's going to be this guy here. Okay? The parent chain is 3 carbons. The 2 carbons is on the right. So we want to use 3 carbons as the more complicated parent. Okay? Now we want to identify substituents. This is a chloro group. This is an ethoxy group. To number the parent chain identified in purple, we want to number from right to left to position the lower numberings at those substituents, okay? So, and then we have to alphabetize. So it's going to be 2-chloro, 1-ethoxy propane. Now we're going to have some stereogenic center information here. In the beginning of the name, when you have only one stereogenic center, we're going to put a capital R or a capital S in these parentheses, but the name is going to be 2-chloro, 1-ethoxy, okay, and the parent is propane. It's more complicated than ethane, right? Because it has 1 additional carbon. So is this R or S? Now, I don't have time to review stereochemistry, but what we do is you draw in the missing carbons, missing hydrogens on the stereogenic center, and you prioritize things, okay? So chlorine has the highest priority, hydrogen has the lightest priority, and then we've got 2 carbons that tie, all right? The one on the left has 3 hydrogens attached to it. The one on the right has 1 oxygen. So the oxygen is going to win out. That's going to be priority 2. This carbon will be priority 3. Now you position the lightest substituent back, and you look to see how the priority substituents go. In this case, 1 to 2 to 3 goes counterclockwise, so that means it's going to be S. So that's the full systematic name. Okay, and this is problem 14.1b in your textbook. 14.1d is this. Now look at this molecule. Let's pause for a moment. There's an alcohol functional group, and then there's an ether functional group. The alcohol functional group receives priority. Hands down, it's the most important functional group. Okay, it's like seeing a rock star walking down the street and you're like, whoa, let's grab our phones, let's try to take a picture of that person. Now, because the alcohol is part of a ring, it's going to be carbon 1 here, okay? And the parent chain is going to include the alcohol, okay? So the parent chain is going to be cyclohexanol. That's the parent chain. Now remember, we never say 1 cyclohexanol because it's always assumed to be carbon 1 where that alcohol or that hydroxyl group is. But what we do need to specify is the number at which this ethoxy group is attached. This is going to be 2-ethoxy cyclohexanol, okay? And then you're going to have to specify all the different stereochemistry. It's going to be 1s or R, it's going to be 2s or R, and that's going to be all in the beginning of the name with some parentheses, and then it's going to be 2-ethoxy cyclohexanol, okay? But I'm lazy, I don't want to go into the stereochemistry of this particular problem. But you need to include R or S with each of the stereogenic centers, okay? This molecule is going to be 1R, okay, 2R, I believe, 2-ethoxy cyclohexanol, okay? And I'm just kind of doing this in my head, looking at the priority substituents. Okay, so the first one's R, and the second one's R as well. That's what I got, okay, when I look at it in 3D. All right, so that's it for naming ethers. That should get you started on your homework or whatever else you need to do. Thanks for watching.